Uh, Hello, everyone. So in this video, I would like to go over some of the practice questions which I already posted on eClass. I want to go over the answer of these very important questions. So in the first question, you have this table, and you have two variables. Your political ideology. You could be liberal, you could be moderate, you could be conservative, and the other variable, which is whether you are going to support the right of labor or the right of workers to make a strike or not. So you could be in favor or you could be against that proposal or that right of strike. So we have two variables, as you can see. This variable, this is the first variable, and this is the second. This is the second variable. The first thing you need to do, you need to determine the type of these two variables. So as you can see, these two variables are. So we have three main types. We have nominal, we have ordinal, and we have intervalatio variable. These two variables are nominal variables because we have different categories, but you cannot order, you cannot rank these categories. As long as you cannot rank the categories, so these are nominal variables. Anyway, so this is a bivariate table. This is a two by three. So we have two rows, favor and oppose. So we have two categories for that variable, and we have three categories for that variable. So this is a 2 by 3. This is a 2 by 3 table. So the number of rows is 2. This is one row. This is another row. The number of columns is 3. Of course, we don't count the total. We don't count this total as being one of the rows. The first requirement in this question, I would like you to test if there is a significant difference, if there is a significant relationship between, is there a statistically significant relation between these two nominal variables or not? So here we are going to use the 5-step model to conduct this hypothesis testing. So what is the first step of that model? We have to state our assumptions. So here we have two main assumptions. We must have independent random samples. So these samples, the liberals, the moderate, and the conservatives, they are independent. If you belong to one group, you don't belong to another group. So these categories are independent. The level of measurement of these two variables is a nominal. It's a nominal variable. Here we are going to use the chi-square test. So the chi-square is mainly used to test if there is a significant relation or a significant association between two ordinal or two nominal variables. Here in that situation, it's a what? It's two nominal. So we have nominal variables. So both ideology and the support, both of them are nominal variables. Even if we have ordinal, we still can use the chi-square. We can still use the chi-square test. So these are the assumptions that you have to make. The second step, we have to state our H node and H1, the null and the alternative hypothesis. These numbers that are given in each cell, these are the observed frequencies. FO, the observed frequencies. FE is the expected. It's the expected frequencies. These are the frequencies that we expect if the two variables were independent. And we would like to test if what we observe, if these observed frequencies are the same as the expected ones, which indicate that the variables are independent, they are unrelated, or they are different. If there is a significant difference between the observed and the expected frequencies, it means the two variables are related. There is a significant relationship or a significant association between these two nominal variables. The third step, we have to determine which distribution are we going to use, the Z or the T or the F. No, we are not going to use any one of these. We are going to use, as I said, we are going to use the chi-square distribution. So the chi-square is used to test if there is a significant relationship between nominal or ordinal variables. Since these two variables are nominal, So we have to use the chi-square test. So we're going to use the chi-square distribution. So I need to go and get the chi-square critical for us. So there will be a chi-square critical table that will be given for you as part of the exam. For you to get that critical value, you need two things. You need to know the alpha. Usually alpha is 5%. So the question says, I want you to use alpha to be 5%. So this is the significance level. And we need to get the degree of freedom. The degree of freedom is R minus 1 times C minus 1. R is the number of rows. So as you can see, we have one row, we have another row. As I said, we don't count the total as a row. So we have two. So for this variable, we have two categories. You could either favor or oppose. So it's a 2 by 3. So R, this R is 2, and the number of C is the number of columns. So this is the number of what? This is the number of rows, and C is the number of columns. So in our situation, we have 2 rows and we have 3 columns. So the degree of freedom is going to be 2. Then you go to the chi-square table. Let me get you the chi-square table. Here it is. This is the chi-square table that will be provided. This is where you're going to be getting the chi-square critical. So alpha is what? Alpha in this question is 5%. 0.05 is 5%. And the degree of freedom is, as I said, R minus 1 times C minus 1. So it was 2. So the degree of freedom is 2. So you look at this 2. So you have to use this number. This one. So this one, this one, the 5.99. So this one corresponded to what? A degree of freedom of 2, and the alpha to be 5%. So the chi-square critical is 5.99. So the degree of freedom is 2. 2 minus 1 is 1 times 3 minus 2. 3 minus 1 is 2. So 1 times 2 is 2. So the critical chi-square that you get it from the chi-square table is 5.99. The fourth step is to get the chi-square obtained. To get the chi-square, so we get the obtained, we get the critical, and then at the very end we make a comparison. If the obtained is greater than the critical, you reject each one. These are typical steps that we did, even with the Z or with the T or with the F test. So we did the same 5-step. We follow the same 5-step model. You get the critical and you get the obtained, and then you compare the obtained with the critical. If the obtained statistic is greater than the critical, you reject the H node. And so how to get the obtained one? How to get the chi-square obtained? So there is a formula for that will be given in the formula sheet, which is going to be this one. FO, as I said, this is the observed frequencies, which are these numbers. These are the observed. So the FO is the observed. So 381, 394, 381, 120, 394, 229. So I'm going to construct this table. This is what you did in your assignment. You're going to construct this table. You put all the observed frequencies. What you need to calculate the expected frequencies. And how to get the expected frequencies? There is a formula for that. The expected frequency is rho marginal times column marginal divided by n. This is the formula for the expected frequency. So that formula is also going to be given in the formula sheet. So what does it mean, rho marginal? So as you can see, each one of these cells, let me use so each one of these cells, this and this and this and this and this and this, each one of these cells so every cell belongs to a row and a column. So for example, this cell, the 381, this 381 belongs to the first row and the first column. So all what you need to do, you need to multiply the row total. Marginal means total. So you have to multiply the row total and the column total that the cell belongs to. So this 381 belongs to this row. So what is the total of that row? 1094, and belongs to this column. So you have to multiply the 1094 by the 5. So let me calculate this for you. I'm gonna delete this part. So you have assumptions. You have the H node and H1, and you have the chi-square critical that you get from the table. Yeah. Let me delete this one just to have a space. So let me get the expected frequency for this cell, for this one. So what to do for that cell? The expected frequency is going to be what? Is going to be for the 381. The expected frequency is going to be what? It's going to be the 1094 times the 501 divided by n. N is how much? This is the total n. 1704. So this is the expected. This is going to give us the expected frequency of that cell. So how did I get it? I'm going to multiply the. So this cell belongs to the first row and the first column. So I'm going to multiply the total column and the row total and the column total of that cell that this cell belongs to. Let me get the expected frequency for the 120. Expected frequency of the 120. Same idea. So the 120 belongs to this row. So the total of that row is 610 times, and it belongs to that column. The total of that column is 501, and you divide this by n, which is, and then you get it. So the expected frequency for that 381 is going to be 321. For the 120 is going to be 179. Same idea. You do the same idea for the 394. So this one, how to get the expected frequency of this one? You multiply this row total with this column total. So this cell belongs to this guy and belongs to that column. So you multiply this by this and you divide by. So the expected frequency of the 394 is going to be what? 1094 times the 623 divided by the n. N is the total number of cases. Same idea. How to get the expected frequency of this 229 is going to be the same thing. 610 times 623. 610 times 623 divided by 1704. And then you get it. You get the expected frequency. Same idea. You get the expected frequency for that 319. It's going to be how much? So this 319 belongs to this row and this column. So I'm going to multiply 1094 times 580 divided by 1094 times 580 divided by 1704, the n. And then you get it. And then you go to this one, to the 261. So this is the expected frequency. So the expected frequency of the 261 is, so the 261 belongs to this row and this column. So you multiply the row total, the row marginal. Row marginal means the row total. So that cell belongs to this row and this column. You multiply the total of that row and the total of that column. So 610. So you're going to multiply 610 by 580, and you divide that by 1704, and then you get it. Once you get the expected frequencies of these 6 cells, you are going to construct that table, and then you are going to put these expected frequencies. So these are the expected frequencies that you calculated by yourself. So this is the observed frequency for that cell, and this is the corresponding expected frequency of it. This is the observed, this is the expected. So these are the frequencies. The frequencies means the number of cases, the number of individuals. So for example, our sample consists of 1,704 cases. We collected data from 1,704 individuals, and we found that 381 individuals, they are liberals, and they are in favor of that workers' strike. We have 261 individuals are conservative, and they oppose that proposal. So these numbers are frequencies, number of individuals or number of cases. So these are what we observe. These are the observed frequencies. And we need to calculate the expected frequencies using that formula. So the expected frequencies, these are the frequencies that we expect to see if the two variables were unrelated. So if these two variables, if the political ideology and the support were unrelated, or were not correlated, not associated, they are independent, we would have expected to see these frequencies. But these are the observed frequencies. This is what we actually observed. Now we want to test if there is a significant difference between these two or not. So to get the chi-square, so first, after you get the expected frequency and you have already the observed, subtract the observed from the expected. So subtract this from this, you get this column. So 381 minus 321, you get the 59. Same idea, this minus this give you that. So subtract the first from the second, you get the third column. And then you square that column. So 59.35 is squared, you will get this number. So you have to square it. And then you divide that column, that one, you divide it by the expected frequency. So divide this column, this one, by this one. Divide it. And this is what you get. So here what you are trying to do, you are trying to calculate the components of that formula. That formula is going to be given in the formula sheet. You don't need to memorize it. So the chi-square obtained, you have first to subtract these two, and then you square it, and then divide that square by the expected frequency, and then get the summation. And this is the summation. 52.21. So this is the chi-square obtained. 52.21. And the critical, as what I showed you that we got from the chi-square table, it was 5.99. So obviously the obtained is greater than the critical. So we are going to reject the H node. So H node was saying that the two variables were independent, they were unrelated. No, they are related. So there is, based on the test, there is a statistically significant relationship between the political ideology and the support for workers' strike. So there is an association. There is a significant association. Now I want to measure how strong is this association. How strong is this association? Is it weak or moderate or strong? So I have to measure some association measures. So what are the measures that we are going to use with this type of these data? They are nominal variables. So if you have two nominal variables and you want to measure how strong the two nominal variables are associated, we have four measures. We have the maximum difference, and we have the phi, and we have the Kramer's V, and we have the lambda. So we have four measures that are suitable for the nominal variables. So let me start going with these four measures. Now I want to measure how strong. So we already proved, when we conducted the chi-square test, we already found that the obtained chi-square is greater than the critical. So there is a statistically significant association. There is a relation. The two variables are related. How strong they are related, this is what we need to measure using one of four measures. One of the measures is the phi. And this is the formula. It is the chi-square divided by n, the square root of it. So this is one of the measures of association between nominal variables, because we already, from the very beginning, we already identified that the two variables that we are having in the question, they are nominal variables. The second measure is the Cramer's V, and it also uses the chi-square. That's why these two measures, we call them chi-square based measures. So these measures are based on the chi-square. Anyway, what is the chi-square that we already got? What is the obtained chi-square? So this chi-square is the obtained one, which we already got by doing that calculation. By doing that calculation, we already got the chi-square to be 52.21. So that chi-square is 52.21. This one is 52.21. So this is the chi-square obtained that you have to calculate yourself. N is the total number of cases, the total number of, it is the sample size. So in our case, what is the sample size? 1704. This is the N. This is the total N. So this is 1704. Substitute, get the square root. So the phi is 0.175. Now I want to comment on the strength, the magnitude of that number. So here there is a table. Threshold table that we use to determine how strong the association is. And that table, you need to remember it. You need to know it. It's not going to be given in the formula. It's not going to be given in the formula sheet. So from 0 to 10, if that measure is from 0 to 10 or 0 until 0.10, so the association is weak. If it is from 11 to 30, it's going to be moderate. From greater than 30, it's going to be strong. So if it is from 0 to 10 or from 0 to 0.10, 0.10 means 10%. This one is from 11 to 30, so it's from 0.11 until 0.30. So it's moderate. If it is greater than 0.30, so it is strong. As you can see, that measure is 0.17. 0.17, so it lies within this range. So the association is what? So in this question, the two variables that I have, the two nominal variables, there is a moderate association between them. What about the direction of the relation? Is it positive or negative? Here, guys, if you have nominal variables, you cannot determine the direction of the association. Why? Because you cannot say if that variable increases. So if I have, for example, liberal, conservative, and moderate, you have different political ideologies. I cannot rank them. I cannot. If you have gender, for example, male and female and other, you cannot order. You cannot rank these options. So you cannot say as gender increase or as political ideology increase. You cannot order that. So in this case, you cannot talk about direction if the association is positive or negative. Anyway, same idea for Cramer's V. I'm going to substitute for the chi-square obtained, which you already calculated. N is given to be 1704. The second part of the formula, R minus 1. So if you recall, we have two rows. So this is a 2 by 3 table. So that table, we call it bivariate because we have two variables. We call it bivariate table. And what is the order of that, or what is the rank of that table? Is 2 by 3. We have two rows, and we have what? We have 3 columns. So the number of rows is how much? The number of rows is 2. The number of columns is how much? Is 3. Of course, we don't count the total. So for that variable, for the support, we have 2 categories. And for the ideology, we have 3 categories. So it's a 2 by 3. Which number is the minimum? Minimum means the lowest of these two numbers, 2 or 3. Which one is the minimum? Of course, here R minus 1, so 2 minus 1, so that part now is what? That part is 2 minus 1 is 1. 3 minus 1 is what? Is 2. So which one is the minimum? Which number is the smaller number? Of course, 1 is the smaller. So you take the minimum of these two numbers. The minimum of these two numbers. So I'm going to take the 1 because it is smaller than the 2. So 1 times this, 1704, you divide 52 by that and get the square root. Also, the Cramer's V is gonna be this. So based on Cramer's V, also there is a what? There is a moderate association between these two nominal variables. Now I want to measure two more measures. I want to get the lambda and I want to get the maximum difference. Now I want to get the maximum difference, which is a third measure of association for nominal variable. So how to do it? So here, for each column, go and get the percentage of each cell. So how to get the percentage? So out of the 501 of the liberals, that much favor. So what percent is this? So to get the percentage of this cell, so it's going to be 381 divided by what? 501 times 100. So this gives you the percentage of that cell. And this is going to be 76. So this is going to be 70. So that number is going to be 76.05. 76.05%. Same idea. You get 120. So I'm going to divide 120. That 120 by what? By the 501, and you multiply by 100, you're getting the percentage. And that percentage is going to be 23. It's going to be 23.95%. And you have to get the percentage of these cells. So you divide 394 by the 623 and divide 229 by that 623. Don't forget to multiply by 100. So I'm gonna do this. So 394, you divide that by the 623, and you divide by 100. The 229, you divided this by the 623, and you multiply by 100. Same idea, 319 over 580 and times 100, and 261, you divide that by 580 times 100. So what are you getting here? You are getting the percentage, the column, the percentage of each cell out of the total of that column. This number is going to be, let me calculate these ones. So the 394, this one is going to be 63.24%. This number is going to be 36.76%. The 319, that percentage, if you calculate this part, is going to be 55. So 55%. And if you calculate that percentage, is going to be 45. It's going to be, so that part is going to be 45. Let me erase this part. Let me erase that part. I don't want to. Good. So what did we get? We are getting the column, the percentage. This is for each column. We divide each cell frequency by the column, the total. And then for each row, subtract the smallest from the biggest percentage, from the largest. So for the first row, what is the smallest percentage? I have 76, and I have 63, and I have 55. So 55 is the smallest. So where is the largest percentage of that row? The largest percentage is this. So subtract this from this. So 76.05 minus the 55. And you get that difference. 21.01, 21.05. For the second row, where is the smallest? I have 23, I have 36, I have 45. Where is the smallest and largest? The smallest is this, and the largest is this. 45%. So subtract this, the smallest from the largest. So it's going to be 45 minus 23.95. And this will also give me 21.05. Which difference is the maximum? This is the idea of the maximum difference. So which one of these differences is the maximum? They are equal. So the first row difference is 21. The second row difference is also 21. So which one of these differences is the maximum? So the maximum difference is going to be what? The maximum difference is going to be equal to what? 21.05. They are the same. If one of them is smaller than the other, take the biggest one. Take the maximum or the biggest difference. But they are equal difference. So I'm going to take 21. 21 is where? Based on that table, based on that threshold table. 21 is in the second bracket. 21 is between 11 and 30. So in that situation, where we have a what? We have a moderate association. So consistent with the phi and the Kramer's V, which also found that there is a moderate. So based on the phi, based on the Kramer's V, and based on the maximum difference, based on these three measures, there is a moderate association between political ideology and the support for workers' strike. Now I am left with one last measure, which is the lambda. So now I want to calculate the lambda. Let me clean the table back. Let me clean it back. So I'm gonna delete and erase all the calculations that I did. I'm gonna erase these calculations. I want to get the original table. So this was the original. This was the original table that we had. Let me erase this part. So I want to get the lambda. This number was 1094. Good. So now I want to get the lambda. So lambda, and there is a formula that will be given in the formula sheet, which is E1 minus E2 divided by E1. So how to get that E1? So there is a formula for that. So now let me get the E1 and E2, and I will explain what does it mean E1 and E2. So we'll see that this lambda has a pre-interpretation, proportion reduction of error. So when we predict if we know one variable, we can predict the other variable with less error. So there is going to be a reduction in the prediction error, or the error of predicting the other variables. So let's get the E1. So it's n minus largest row total. What is n? So based on this bivariate table that is given in the question, the n is what? The n is 1704. 1704. This is the n. And what is the largest row total? Of course, these two, E1 and E2, are going to be given in the formula sheet. You already have the formula sheet posted on eClass. Have a look on it to make yourself familiar with that formula sheet. So what is n? N is this number 1704, and what is the largest row total? So we have two rows. The first row has a total of 1094. The second row has a total of 610. So which one is the largest row total? This one or this one? Of course, this is the largest. So subtract this from n. So it's n minus the largest, which is 10994. So this give you the E1. So E1 is going to be equal to 610. So that E1 is going to be 610. 610. What about E2? For E2, all what you need to do for each column, subtract the largest cell from the total of that column. So this is the largest cell. Subtract this from this. So 501 minus 381, you're going to get this. So now I'm calculating E2. So how to calculate E2? So 501, you subtract the largest cell. So for each column, subtract the largest cell frequency. So for that column, subtract that largest cell frequency from the total of that column. So minus 381. Good. plus, because at the end you have to sum all these differences. The second column, subtract the largest frequency from that column, the total. So 623 minus 394 plus, subtract this from this, 319 minus 580. And then, so for each column, subtract the largest cell frequency from the column, the total. So this is the largest. You have two numbers here for that column, this and this. Which one is the biggest? This one is the bigger than the 120. Subtract this from this guy. Subtract this from this guy, and subtract this, because this is bigger than the 261. 319 is the largest frequency in that column. Subtract it from the column, the total, and sum. You're going to get the E2 to be 610. I want you to double check these calculations. Double check these calculations to see if there is any calculation mistakes that I did or not. So the E2 is going to be also what? The E2 is going to be 600 and 610. So in that situation, alpha is going to be what? Alpha is going to be, in that situation, in this example, it is 0. So based on the table, from 0 to 10, it's weak. It's a weak association. So in this case, oh guys, there is a typo here, weak association. It's not week or month or day, sorry, weak association. So in that situation, we have a weak association between the two. So Kramer's V, phi, and maximum difference say that there is a moderate, but lambda says that there is a weak. So what we can say is there is a weak to moderate association between these two nominal variables. Suppose we calculated this lambda, and suppose we found the lambda not to be 0. Suppose it was 0.20. Suppose our calculation got a lambda of 0.20. What is the meaning of 20? What is the meaning of 20? The meaning of 20 is knowing your political ideology. So here we have two variables. How political ideology affects your support. So this support is the dependent variable. So we have support, how it is a function of your ideology. So this is what? This is the y, and this is the x. Y means dependent. This is the dependent variable, and the x is the what? Is the independent variable. And we want to see if your ideology affects your support for that reform or for that labor strike. So here, knowing the x, if I know your ideology, if I know your x, if I know whether you are liberal or moderate or conservative, if I know that, I will be able to predict. This is going to increase our ability to predict whether you are going to favor or oppose. So this will help me to predict your support by 20%. By 20%. This is going to increase our ability to predict the Y or the support by 20%. Or we can say, knowing the political ideology, knowing the X, if I know your ideology, our ability, the error of predicting the support is gonna decrease. This is gonna reduce the error of predicting the support by 20%. That's why we call it proportional reduction of error. So that formula is proportional reduction of error, PRE. Proportional. This is the P reduction. That is the R of error. proportional reduction of error. So the error of predicting whether you're going to support or dis-support, the error, of course, when I predict, there is a chance that my prediction is wrong, so that there is an error. But if I know your political ideology, this is going to reduce. This is going to reduce my prediction error by what? By 20%. This is the meaning of, or this is the interpretation of the lambda. So let me summarize this question. In this question, I wanted to check first if there is a significant association between the two variables. So I had to use the chi-square test. I had to follow the 5 steps model. I got the chi-square obtained. You still have to state your assumption, put your H node and H1, and then get the chi-square critical from the chi-square table, get the chi-square obtained. So you have to construct that table that I was putting here, the FO, the observed, versus the expected frequency. So you have to calculate the expected frequency as I showed it before. And then you get the chi-square obtained. You go to the table, the chi-square table, get the critical, compare the chi-square obtained with the critical. And if the chi-square obtained is greater than the critical, so there is a statistically significant association between these two variables. How strong that association is, we can use one of 4 measures. We can use maximum difference, phi, Kramer's V, and lambda. So we have four different measures of association for nominal variables.